Right, number 6. Today we'll talk about a couple of things, and mostly we'll be having a lecture in the class today with bits and pieces of demo. Unlike the last two lectures where it was primarily hands-on, this is a lot of slides mixed with hands-on today. Okay, but mostly slides. So this is going to be the last lecture in Python before we move on to HPC starting next week. So today we'll talk about lists and tuples and NumPy arrays. So these data structures are very useful for managing data in scientific computing exercises. Then we'll talk about modules. Well, mostly we have talked about it, but we'll touch upon it again for a couple of things. I'll talk about functions, and then towards the end I will talk about something called Pythonic way of doing things. Just touch upon those ideas so that we know that there is something called Pythonic ways of doing things which make things either much more compact or sometimes much faster, or sometimes both. Right, and then towards the end we'll do some demo on timing codes, which is actually a very useful thing when you're doing anything to do with heavy duty computing, because you want things to finish in a less amount of time. Okay, so you want to understand how long a code is taking, or how long a code snippet is taking for it to run. So we'll learn how to time codes in Python, okay, so that we get some motivation to move on to faster programming languages starting next week. Right, so Python is an object-oriented language. So some of you may understand what it means, and those who don't, well, object-oriented basically means that it's a well-organized way to handle data and as well as functions. It's very difficult to explain that right away, but it's not actually needed. I'll just give you some examples to explain what it means in a more hand-wavy sense. But the advantages of Python over other languages can be that it's interactive. So you can write a command, press enter, and see the result right away if the command takes a small amount of time to run. Unlike other compiled languages where you actually have to write the whole code, compile it, and then run it to see what happens. You can also write scripts. It's just not interpreted commands, but you can write a whole script and run it if that is what you need, and towards the end that is what typically you will want to do. There is a very little overhead to start writing programs in Python. Like we saw that when you start Python, when a Python shell starts, it's very quick. That's because it does not load many modules to start with. So if you want to do anything, you have to load the right kind of modules or functions or variables. The graphics and visualizations typically are quite good. So as I said last time, and I gave you a short demo of matplotlib as well. Whenever you do scientific computing, you will definitely most probably be using Python for plotting things, okay, for reports or publications and so on. One good thing about Python is that you can easily combine this language with other languages, like compiled languages. So an example is, for example, NumPy that I demonstrated to you. And doing things with NumPy functions is very quick. We'll demonstrate that when we talk about timing codes today. And the reason is because NumPy under the hood is actually using a C code, a compiled C code. So in this course, we'll learn how to write programs in Fortran, for example, and the program will be very quick because it's written in a compiled language. And then you can convert that to a Python module, and you can import that in Python. So that way is you can yourself write modules, and then you can use it in Python. It's a very useful exercise. It's a very powerful thing to do, because sometimes passing data and playing around with that data into a function many a times when you're trying out things is too frustrating in compiled languages. But with Python, if you have a module, if you have made a module, a Python module which was initially written, a function written in Fortran or C or some other compiled language, then you can play around with it very quickly. Okay, so towards the end of the course we'll see how to write Fortran wrappers into Python, and it's open source and runs on all platforms. That's one of the major advantages of Python, that it's even on Raspberry Pis, small microprocessors. You can and it's available by default in OS, for example, Raspbian and so on. So it's available by default. So if you know Python, then you can actually do a lot of things in different places and domains. One of the major disadvantages is that it is slow in many things. Okay, so that is the reason you tend to go to compiled languages to write scientific computing codes, but then you can use them in Python, as I said, through wrappers. Wrappers, the wrapper that we'll talk about is called F2Py. Okay, so this is used to convert a Fortran compiled code into a Python module. So then you can import that using import command. There's also something called Cython, which is used for C, like for F2Py is used for Fortran, to include that in Python. So for prototyping, Python is amazing, but for anything to do with scientific computing, heavy duty computing, that is going to take a lot of time, many days or months. You'll tend to go for something which is much faster and include the ideas of parallelization and so on that we'll be discussing over the course of this semester. Any questions? Right, so let's briefly talk about what is the meaning of object in an object oriented language. So as I said, I'll talk about this in a very hand wavy sense. It might not do justice to the depth of object oriented languages that they have, but let's take a very simple example that objects are basically objects of something called classes, and the classes will have two types of things. One is called data and the other is called functions. Okay, so data is, as the name suggests, that they will have some information, some data, and functions are, as the name suggests, are things that allow you to interact with the object. Okay, a very basic example is, for example, if you have integer. So integers it can be a class, and the objects could be different integers, 1, 2, 3, 4, and so on, and functions could be add integers, multiply integers, and so on. So these are functions that you can have. Here's another example that I've included here is a class called mountain. Okay, so mountain is a class, and the objects of that could be different mountains. So different mountains are different objects, and what sort of data or attributes they have. Every mountain would have an altitude, a difficulty in terms of climbing it, the country where it's located, and so on. So these are different attributes or data for the class mountain, and functions could be if you want to set the altitude of a given mountain. So that is a function. You are doing something to a data in that class. So this will be called a function, right? And then how would you extract information? So if I have created an object called Everest as an object of the class mountain, then to extract the altitude value for that, I'll say Everest dot altitude, and that will be equal to the value. And or if I want to call a function, so I'll say, for example, Hanuman Tibba is a mountain in Himachal. So you say Hanuman Tibba dot set altitude, and then you set the value. So that will set the value of the variable called altitude for that object to be equal to 5982 in this case. All right. Why are we talking about these things? Is because they are important for certain aspects that we'll be talking about today. So when you create new variables in Python, so we have been creating variables, right? We say x equal to 2.0, for example. So what happens in that case? So x, the variable that we're talking about, is actually a variable that is pointing to an object of some class. In this case, since it's 2.0, so it's a real number. It's a floating point number, as we've discussed, IEEE floating float. So there is a class called float. So what happens is when you say x equal to 2.0, an object of this class called float gets created, and the variable x simply points to that object. So object, you can think of object as some memory, some space taken in the memory of the computer, RAM of the computer. So that RAM, that space that you've created in the memory of the computer is being pointed to by the variable x. So if you do something to that space, then basically x will still keep pointing to it, but x by its nature will not change. It's simply a pointer pointing to an object which is located in the memory of the computer. And that is important for us to understand, as we'll see in the next few slides. But just remember this idea that variables by themselves do not have a type. So I won't say x Well, I can loosely say that x is an integer, x is a real number or a float here, but actually x is simply a variable. X is pointing to an object which is an object of the class called float, and this is different from what you have in compiled languages. In Fortran, which is in a procedural language, we have variables which have type. So there in Fortran, for example, you'll say x has a type called float, but here x is simply a variable. So you can straight away change in the next line. You can say x equal to double quotes hello. So that becomes a string. So now x starts pointing to another location in the memory, which is a location taken by an object of the type called string. Okay. So here I have included some snippets from an exercise. I'll give you some time to try it out. We'll try it out together. But let's try to understand the ideas here first. So first what we do is, so this is on a Python shell. So we say x equal to 3.4. So we have initialized x equal to 3.4. So what that means is that you've created an object of the class float and you've given it a value called 3.4 and x is pointing to it. So now if I say print id of x, so id is a function in Python that returns the location, memory location of the object. So this gives you some number. So this number basically points to some memory location in the RAM or the memory of the computer. And if we say type of x, that will return, in this case it will return float. So this is actually the what the command will return. So type float. So this float here is an object, is a class. So basically it says that your x is pointing to an object which is of type float. So in the next line I say x equal to 5. Now if I do the same thing again, you see that the memory location changes. So what happens is x equal to 5 generated an object, a new object in a different memory location, and now x starts pointing to it. So if I say id of x and type of x, they're again completely different, because now the x is pointing to a different location of a different type. Again, if I make x equal to a list 4, 5, 6, so in this case if we say id of x and type of x, now you can see that the memory location again has changed, because you have created a new object and the type is now also different. Right. So if I keep doing this again and again, you will see that every time I do it, a new object gets created, the way we are doing things here. Is that clear? Any questions?
Sir, once we define the value of x, like say from integer to float or float to integer, what happens to the previous space in the memory?
I mean, it's made available again. So it's you don't have any control over it. That's gone.
So the information or the variable that we create in the previous memory,
It's destroyed.
it's destroyed.
Right. Now let's continue from the last line. So what we had said was x equal to 7, 8, 9, and if you print id of x and type of x, you get this id and type. Now if I say x dot append, so x is a list here, and lists provide a function, the list class provides a function called append, which allows you to append information to the end of the list. So if I say x dot append of 10, 10 being an integer here, then it appends the value or the value 10 here, and now if you print id of x, you see it's exactly the same as last time. So objects are of two types in Python. One is called mutable and the other is called immutable. So mutable means that you can mutate, you can change it, and immutable means you cannot change it. So here list is an object of type called mutable object. You can change it, you can modify it, and that is the reason the memory location did not change. What it did was it added another item to it, but x is still pointing to that list. So if you say x dot append of 10, it does not create a new list. It's exactly the same list with some more information added to the end of it. Okay. So we must understand what is mutable and what is immutable for reasons, and almost everyone who has done programming in the past will make that error that I'll show you soon. So that's the reason we are discussing this idea. So let's say we say x equal to 1, 2, 3 like this, and then I print id of x and the value of x, and now I say y equal to x. right? I mean, you may want to do that. You may want to copy the value of x into another list y and play around with it. So what I did was I did y equal to x to create a copy of x, and then I changed y. I added something to y called 27, and now I print the value of y and x. They are both modified. So when you say y equal to x here, y simply starts pointing to the same location where x was pointing. So it's basically like, you know, both of them have control over the location where of that list. You have given y also the control to modify that location. So you may or may not want to do it, right? In some cases you may not want to do it, as I said, that you just want to create a copy of x and play around with it without touching x. In some cases you may want to do it where you want both of them to have control over the location for some reason, I don't know. Okay. So one has to be careful that for these kind of mutable objects, it can happen that like lists particularly that we deal with a lot in Python, that if you want to create a copy, you must create a copy properly. Is that clear? This is a very important idea, so I want to make sure that everybody is clear about it. Right. So how do we create copies? In fact, I would want to demonstrate this rather than just talk about it. It's an important idea. Right. So let's start up an IPython shell. So I'll activate the virtual environment for this course so that IPython is available. So let's create x as a list of 3 items, 1, 2 and 3, all being integers. So if I type id of x, it should return the id of x. That's the location where the list is stored. And if we do a type of x, that returns a type list. Right. Now if I want to create a copy here, there are different ways to do it. Let's try a very basic ways, something called, well, first let's try y equal to x. Let's say I want to do, if I do this, and now if I do, if I check the value of y and x, they are both the same. Now if we append something to y, let's say the integer 5, and now if I print the value of y, y has been modified as expected, but x also gets modified, as we can see here, and that is something that we do not want to do in this case. I want to actually create a copy. So what I do is, let's call it yy as, I'll say list, and I'll pass the list x into it. So list function will create a copy in this case. So let's see what yy looks like. So x actually is same as yy. Now let's append something to yy, let's say 7. And if I see the value of yy has been modified with an item 7, but if I check x, it is still the same as last time. So I'm happy that this is what I wanted to do. I wanted to create a copy of list x, so I can use something called the list function here. There's also a copy function. I think it does the same thing as list. So if I say copy of x, maybe x dot copy. Right. So this copy is a member function of the object of type list. So I can say, let's say double q is equal to x dot copy. So this double q becomes 1, 2, 3, 5, which is the same as x. And if I append something to double q at this time, let's say 44, so that gets appended, but x is still the same. So you can use either the list function, or you can use the member function of the type list as copy. So to call copy, you'll have to say the object, which is x in this case, dot copy, and then you can pass whatever it returns, the new copy, into some other variable. Some other variable can start pointing to this new copy. Right. So let's also see the id of x in this case, which is 1399 blah 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 was something, and then I can print the id of qq in this case, which is different. So they're pointing to a different list. Any questions? So x has 4 items in this case, and how do we refer to the items of x? I say x bracket 0, so that returns the first item. Then if I say x, so the indexing starts from 0 in Python, so x bracket 1, that returns the second item, and so on till x bracket 3, which is the last item, 0 1 2 3, the fourth item. And if I say x bracket 4, then index out of range, because the list only had 4 items in this case. So let me print the id of x again, and I also print the id of x of 0. Okay, so we see that they are different. Okay, they're different for a certain reason, but that's okay, don't worry about that. But if I see the id of x of 1, that's again different from id of x of 0. So it's like, the 4 items in the list are kept at different memory locations. Right, so they are different locations where the 4 numbers are kept in the memory. Let's check the id of QQ, which was created using x.copy. So that is, reduce the size a bit. So you can see that this id of x and id of q, they are 2 different values. Let's look at id of let's print the value of q first, sorry, QQ, and this is x. So let's print the id of x of 0, and also print the id of QQ of 0. So we notice something interesting here, that they are both the same. Okay. So what if, I mean, that's a question for you to figure out. What if I say x of 0, I modify it by saying x of 0 equal to 100. Now if I print the value of x, x of 0 has changed. What do you think will happen to QQ this time? Will it be the same or will it have changed? Different, right? So now if I print the id of QQ of 0, this is the same as earlier. This has changed. So Python is trying, I mean, it's a smart language. So what it's trying to do is, unless you change it, why should I create a copy of the object? I mean, the number 1. If you change it, then I'll create a new copy. So they are different, but still, if you really want to keep them the same and only add something to it, so I'll just have the information that these 4 numbers are still the same. So let's maintain 1 copy. Why waste memory in this case? But if you modify it, then it starts creating a new memory. So Python is smart in that sense. So do play around with these things, because as I said that most of you will make or create an error of this kind once in your lifetime if you work with Python, of modifying something which should not have been modified in a list, and they're still pointing to it the same location and so on. So mutable objects, you have to be careful about them. Now there's one more thing in this list called deep copy. To explain what it means, let me do a demo and see a minimum working example of what we should not be doing. Okay, what goes wrong and why we need something called a deep copy. So let's clear the screen. So this time I'll initialize x to a list of lists, and that is allowed. So the first item in this list is 1, 2, and the second item is 3, 4. So it's like a matrix. Loosely speaking, it looks like a matrix, right? It has 2 rows. The first row is 1, 2, the second row is 3, 4. So if I do that, I print the value of x. So it's a list that contains two objects. The first one is a list and the second one is also a list. And by the way, lists are quite flexible. You can actually have you can do x dot append, and then you can append some text to it. So now x is a list which has three items. The first one is a list, second one is a list, and the third one is a string. Okay. But that is not what we want. So let's clear it and then say x is equal to a matrix or a list of two lists 1, 2 and 3, 4. Now let's say we want to create a copy of this. So I'll say y equal to x dot copy. So y becomes the same. Now if I let's also print the IDs of the two, ID of x and ID of y. We can see they are different, although they have the same content, but it's a copy. Now let's also do one thing. Let's modify an item of y. So how do I refer to a different item? So if I say y of 0, now y is a list now, and the first item of this list y is a list called 1, 2. So if I refer to y of 0, it gives me the first item of the list, which is 1, 2. If I want to refer to the second item of this list, so I should say that I want to refer to the second item of this list 1, 2. So I get 1, 2 by saying y of 0, and then I get the second item by saying the index 1 of that. So let's modify it to 100. So now if I print the value of y, I get this. What do you think will happen if I print the value of x? What should I get? 1, 2, 3, 4 or 100, 3, 4? Well, of course, what you expected was not going to happen. That's the reason we're talking about deep copy. Okay, so copy, what it does is it copies up to one level. But if you have list inside a list and so on, then deep copy does not copy to multiple levels. So for that you need to have something called deep copy. Okay, I just want to tell you this because I have made these mistakes in the past, because we tend to deal with lists of lists, because we deal with matrices and so on. So it's worth knowing this idea. Okay, so the way you create copies of these multi-dimensional lists, so to say, is you import a module called copy, and then you say y equal to, or let's do y equal to different from y, copy dot deep copy. So deep copy is a function that's available in the copy module. Of x, sorry. So yy is the same as x here, but now if I modify yy, let's say yy of 0, 1 is equal to 200 this time. Sorry, yy is modified now, but x remains the same. So if you have this kind of situation, you want to deal with something called deep copy. And when people create objects of custom type, they tend to have these variables called copy and deep copy. So they overload these functions to ensure that depending on the classes you are creating, they may have functions called copy and deep copy. But if you understand this idea of copy and deep copy for lists, deep copies, it copies to nth level, whatever levels you have, everything gets copied. But simple copy will only copy to one level. So if you have any questions, play around with it, check the documentation for these functions on the Python website. You will get plenty of information, but do be careful about these things. Right. Right. So as I said that unlike lists, integer, int, float classes like this are immutable. That is, you cannot modify them. So there is an example here. So I say x equal to 3.4. I print its ID and location and value. This is what I get. If I say y equal to x, then if I print its ID, I get the same thing. But that is again, Python is being smart, it's trying to save you space. If you do y equal to something, y equal to 100 or y equal to y plus 1, whatever, if you try to modify y, then you check the ID of y, it has changed, because integers are immutable. Okay, so saying y equal to x and modifying y will not change x. X will still be the same. If y is equal to x and y has not been changed, or x has not been changed, there is still Python is being smart, so it's pointing to the same location just to save you some space. But if you modify any one of those, then the other one will still stay the same. Whatever, let's say you have changed y here, so y gets modified. So now if we print the ID of y and x, they are different, the same way we saw in the copy example. Okay, so I'll upload these slides for you to practice after the end of the first half. So do play around with these things. And these kind of ideas create very good questions for quizzes also. Okay, so if you have tried out these things, then you will do well in the quiz. Well, I've already talked about it. So elements of list can be of any type of objects. So here the list L has 4 objects. The first one is an integer, second one is a float, third one is a string of characters or a string, and the fourth one is a list which contains 2 integers. And I've also talked about how to index this multi-dimensional lists. So to refer to the item 1 in this last list, you will first refer to this list 1 comma 2 by saying L of 3, which is the 4th item in the list L, and then we will say that we want the first item of that list, so we will say the index 0. So that becomes L30. So mostly people who are coming from MATLAB or Fortran, they will make an error of starting with the wrong index, because Fortran starts with 1, not 0. MATLAB also starts with 1, I guess, right? So we may end up making a mistake, but especially when you work with multiple languages, but keep an eye out for these things. So list being a class has member functions. I've just included one here called pop. Pop is to take it out. So L is a list here which has 4 items, and if I say L2 is equal to L dot pop of 2, so the 2th index refers to the 3rd item in L, which is ABC. So if you are saying that L dot pop of 2, it basically takes the item ABC out of L. And where do you want to put it? You want to put it in L2. That's what the second command says. So that what happens is L gets modified by 1 item removed, and the list L2 has 1 item called ABC. So these kind of functions are available, which tend to save you some trouble of copying information. You can simply take it out, and Python under the hood will figure out how to do it. So there append I have shown. There is also an insert to insert an object somewhere. Sort, reverse, remove, and so on. All these items, all these functions are available. Okay, so you should try it out yourself to see that since L2 what it has is 1 item from L, it will make sense that Python does not create a new memory space. So you will see that the ID of L2 and ID of L of 2, which was where ABC was initially there, they should be the same, but do check it out yourself when you play around with these things. So let's talk a bit more about indexing. So let's say X is a list of 4 numbers, 1, 2, 3, 4. So as I said, X of 0 is the first item. So if I say X of 0 to 2, so this colon is for a range. So X of 0 to 2 says that you want to extract items from 0 to 2, but not the 2th item. So one less than the last. Okay, so when you say X of 0 to 2, it extracts items 0 and 1. So if I say X of 0 to 3, it extracts the item 0, 1 and 2. So the last one is not included, it's one less than the last one that is there. Now I don't know the length of x. Let's say if I say x of minus 1, it automatically gives me the last item of x. Okay, so x of 0 is the first item, so x of minus 1 is sort of the one before that, and if you circle it around, then you get the last item. That's just one way to index. So this is called indexing lists in Python. Right, so let's talk about something called tuple. Tuple is also like list, very similar, except that tuple, unlike list, is immutable. Now, there are situations where you want to make sure that you yourself or somebody else who is referring to your code may not modify the contents of that initial list. You want to freeze it. So what you would want to do is you would want to create a tuple. So the way you create a tuple is very much similar to a list, except that instead of square brackets you have parentheses. So you say t is equal to 3, 4.5 and ABC. So it creates a tuple of 3 items, and then you can you index using the same ideas. But if you try to modify an item in t, like you did above in the list, it will give you an error saying that tuple object does not support assignment. You cannot modify. Once you've created that, that's frozen. So exactly like list, except that it is immutable. So we have talked enough about modules in Python, but let's talk a bit more about it. So we have already discussed the idea of importing modules. To do anything interesting, you have to import module, and that's one of the reasons Python is very quick. It does not load a lot of things beforehand. But sometimes you will want to figure out what is a module. So module is simply a Python script. So we had written a script called mysquareroot.py, and we were importing it, remember? So we said import mysquareroot. So it automatically looks for a file called mysquareroot.py. But where does it look for that file? So by default it looks for that file or module, as we call it, in the same folder where you are working right now. Okay, so let's say that module is sitting somewhere else in some library folder. So how will Python figure out where to find these scripts? So for that there's something called a path, a default path where Python should be looking for these things. So there is, so whenever you start Python and you import a library called sys, and then you say sys.path, it will return a list which has different paths in it. So basically what Python does is, in the order of the items in the list, it will start looking for that file that you're trying to import. So if the file exists in any one of those, it will import it, otherwise it will throw an error that module was not found. In case you want to modify that path, all you have to do is, because it's a list, let's say I create a new Python script that I want the user to be able to import. So what I'll do is I'll simply append to that path, which is a list, as my new directory, and then you can import it. Okay, there's always an empty string in the list, so that basically means this folder, wherever you are, it will refer to that folder. So let's try it out. It's a very useful idea. So as I said, let's import sys, and if I say sys.path, so you see that it prints a list which has a certain number of items. I can look at the length of the list as using a length function. So it has 6 items in it. So here we see that it has these 6 paths. The first one being the virtual environment /venv/bin. So first it will try to look into that virtual environment that we have created. Then it looks at the default computers folder called user lib python 310.zip. Then it looks for something in this folder. Then it looks for in this folder. So when you install Python, it also installs other things with it. So they are located in some folder. So by default, it will change these default. And then the fourth one, sorry, the fifth one is the present folder, and the sixth one is some other folder in the virtual environment. So if you have the same library available at different locations, then it will look for the wherever it's found first, that will be imported. Okay. So let's try to import my square root that we had created. It cannot find this module anywhere in this list, and that makes sense because that's sitting in some folder in the repository that we have. Let's find out. So I've created a new shell. So let's look for the location of my square root. Right, so this my square root.py is sitting in this folder called GitHub HPSC 24 codes Python my square root. So what I can do is I can simply copy this. Let's do a CD. Let's get the whole path. I want the absolute path here. And now what I'll do is I'll append to sys.path because that's a list. So I include this path. So now if we check the sys.path here, you can see the last one has this directory where my square root is there. So now if we import my square root, that gets imported. All right. So if you have a folder where you have these modules available, it's always good to include that in the sys.path list. That's one way. Is that clear? There's another way through an environment variable in terminal. The variable is called Python path, and those who have installed something by compiling a code may have realized that, and that's especially when it becomes useful, because if you're trying to install a code by configuring and making it, and while installing the code, it's trying to look for a library because it's trying to run a Python code in the background. And you don't really want to go into Python and modify the sys.path. So what you can do is, because you are calling the install command in the terminal, you can modify a variable called Python path, and then it will also look for the modules in the folders available in the Python path that you have. So let's look at a demo here. So let me exit from here and then start IPython again. Well, let's not use IPython. Let's say we want to run a Python code. So Python is available, right? So let's say I want to run a Python script, and I can create a script, and inside the script I can so let's create a script. Let me see where I am right now. So I am in home. That's okay. So let's create a folder, because I don't want to put files into the home. So let's say test folder. So I'll delete it later. Let's go into this. Let's create a script. I'll call it temp1.py. So let's try to include my square root. So we'll say import let's see what we have in my square root, because ultimately I'll want to do something with it. Well, it has square root 2 function, so let's use that function. Okay, and then we'll say sqrt2 of 3.0, and I also want to make debug equal to true here, so that I can see the whole list of steps of iterations and the value of the square root guess s, or square root estimate s. So if I call it, it should print everything on the command. That's pretty much it. That's what the command is. That's what the code is. So let's close it. I can check the code here by looking at temp1.py. So it has 2 lines. For my square root import sqrt2, and sqrt2 function is being called with 3.0 and 2 as 2 arguments. So let's run it. And as expected, it says no module named mysqrt. So what do I do here? So what I can do is I can first check the value of the environment variable, what exactly it is right now. So I can do echo and then dollar Python path. So it's an empty variable for now. Okay, so it has nothing. By the way, there's another command called print env. Rather than echo dollar, you can also use print env, and then you don't need to put dollar. Then you can simply say the variable name Python path. It's nothing. Well, just to check that this command is working, if I say home, it gives me home is a variable which has the location of home. ps1 which is something which has the prompt here. Don't worry about what it has. It's a regular expression, but this is so this command is working, right? So Python path has nothing. So what I can do is I can set the path into this variable Python path. So I can say export, and then here I have to give the whole path, which is here. So if I look at the environment variable now, so now the variable has this path /home /HPSC and so on. The whole path is there. Now let's try to run the command. So I say Python and then temp1, and now you see it runs. So it's very useful to modify the Python path environment variable because you will not be using IPython every time. So you don't want to modify the sys.path inside the code. So without changing the code, we were able to allow the code to access the mysquareroot.py in the import. Okay, and you can have multiple paths here like list. The only thing is that they are separated by a colon. So I can say, let's say I want to add another path to it. So you say export Python path. Now this time I will, let's say a Python path already has many things and you want to add one more thing to the list. You will simply say that first whatever the Python path is, and then it puts a colon there, and then it adds this. So if you do this, then whatever was there in Python path will get copied, and then after that a colon, and then the new path that you have. So let's say the new path, you also wanted to look to find this in the folder called Python. So I give this, and now if you look at the environment variable, so it has the old path which was this one, then a colon, and then it has another one called Python. So now what it does is it will look for that file first in my square root and then in the folder called Python. Any questions on this?
So when we change the variable Python path, will it automatically apply for all the Python files that we make in the future? Like if we want to.
It's only in this terminal. So that's a good question. Let's start a new terminal and look at the Python path. It's empty, right? So it only modifies that environment variable in that terminal that you're working with. If you want that path to go into your all the terminals, you have to modify the .bash rc file so that it automatically sources that file. There's also a variable called path. So when you try to call an executable, it looks for that executable by default into these paths typically. So first it will look into the virtual environment because you have enabled that. But if I don't enable the virtual environment, so let's say I start a new terminal and I say print env of path, it does not, it has a different path. Okay, so when you source the virtual environment, then it modifies this default path. So path is for calling executables. So if for some reason your virtual environment is not getting sourced, enabled, that's okay. You can always call the file directly, or you can include the path of that virtual environment into your path environment variable that you have. You can simply append into it using the export command. So one more thing I was trying to show you, but I didn't want to include too many things to mix things up. You can also call, if you have a short Python code that you want to run and you don't want to go into as a script, but you don't really want to go to IPython or something. So you can simply say Python -c, and then you can have the code here. So let's say I say import my square root, and then the next line I want is, so you can separate the two lines using semicolon. Next is you want to call it sorry, import, yeah, that's okay, my square root dot sqrt2, and now you want to call it with 2.0 and true. So it runs it. Okay, so it's like I created a script with two lines. I didn't really need to. I can simply have this command Python -c, and then I can have these commands here. It'll run this as a script. So you don't need to load IPython shell. You can do it on Python directly. So I can now play around with values. I can change it to 4 and then see what happens. I can change it to I can remove the true and then see what happens, and so on. So if you have a multi-line code that you want to run, you don't need to launch IPython. You can simply use Python, and then you can write the whole code into the codes. It's like running a script. Any questions? So let's see if we have deserved a break here. Well, modules, let's finish this off. So we already have discussed that if you want to import something, there are different ways. Let's not repeat it, we have done it. So let's take a break here, and then we will start with the discussion on arrays, which is a more useful data structure for us in scientific computing. So 5 minutes.